Remember that if we use the maximum distance between any two sample means, that's pretty much finding the range of all the sample means. And this doesn't give us a good measure of the variability of sample means. That's because we could add a bunch of samples to this data set whose means are within this range, and the variability then wouldn't change if we use the range as that measure. We want to account for all samples. You also found before that the average deviation adds to 0, so this can't work either. If we find the distance each sample mean is from each of the other sample means, then we might as well do a bunch of t-tests. We'll have to do the same number of these calculations as t-tests anyway, and t-tests are a better measure of whether or not two samples are statistically different. We've reached our answer. Find the average squared deviation of each sample mean from the total mean. Since we're only concerned with the variability between means, for now we're not concerned with the variability between each sample. We're only looking at the mean of each sample. And remember, this is how you calculated the standard deviation. If we had a data set and we find the mean, we found each squared deviation from the mean. And then in the case of a sample standard deviation, we divided by n minus 1. That's exactly what we're going to do when we find the variability between means. The average squared deviation of each value in each sample from the total mean also includes the error caused by individual differences between subjects in each sample. And we don't want to include this error in our measure of between subjects variability. This is the total sum of squares, and we'll reference back to this later. For now, we're only concerned with the squared deviations of each sample mean from the total mean, the mean of all values from all samples. This total mean is called the grand mean in statistical terms. And we're going to denote this by x bar sub g.